Hi, today we're going to go through the basic functions of the SIGLEN digital oscilloscope that you'll be using in your PVB 203 practical class. Now let's get started. Here we have the oscilloscope interface. This is the main screen, which will display two-dimensional waveforms with the voltage being on the y-axis and time on the x-axis. Below the screen, you have a row of soft keys that can be activated by some of the features we will explore in this video. Moving to the right of the screen, we have the vertical settings for the voltage and the horizontal settings for time. This oscilloscope has two channels, which will allow you to measure up to two inputs at once. Now, we will set up these inputs from the signal generator. The first channel will be set at 1 kHz and 5 volts. The second channel, which we will now turn on, will be set to 2 kHz and 10 volts. You can adjust the voltage setting individually, but not for the time setting. On the vertical or voltage setting panel, we have the voltage variable and position knobs for channel 1 and again for channel 2. The variable knob adjusts the height of the waveform, while the position knob adjusts the position of the waveform along the y-axis. The value appearing momentarily on the screen is the voltage value you've just adjusted to. The horizontal or time setting panel also has the variable and position knobs. In this case, the waveform width is adjusted, either showing less or more cycles. The position knob for the horizontal setting moves the waveform either left or right along the x-axis. Note that the variable knob for the vertical allows for fine and coarse adjustments. Simply press it to switch between the two modes. Further to the right, we have the trigger settings. Triggering synchronizes the y-axis and x-axis waveform outputs so that you can see the waveform fixed to a single point. In other words, this stabilizes your waveform and makes it easy to analyze. What you're seeing here now is an unsynchronized waveform, or unstable waveform. Leave the setting on auto while stabilizing the waveform. Now, if we set the trigger condition correctly, we will get a synchronized waveform as shown. To set your trigger condition, use the trigger level knob. Adjust where your trigger point will be, which is generally on the midway point of the positive slope. This may not be the case for your waveform, so do a quick survey along the entire slope before setting the trigger condition. An icon on the right side of your display screen indicates where your trigger point is. There are three trigger modes as shown on the panel here. The single mode stops further data input once the trigger condition is met. This is something like a snapshot, where if we move the signal in the horizontal direction, we can only see the waveform that was just captured on the screen. We can tell it's on single mode by the stop icon here at the top of the screen and the red on the run stop button. Now, we'll return the waveform to the original location. In the normal mode, data input is continuous once the trigger condition is met. The icon will be blue and the run stop button green. If the trigger condition is not met, the untriggered waveform is displayed. The normal mode is also useful for preventing the oscilloscope from auto-triggering, which is the default setting. Unless your signal is unpredictable and requires stabilizing, you can leave the trigger mode on auto. It's recommended that you set the oscilloscope back to the default settings before scaling your waveforms. You can do this by pressing the default button. There are three things to adjust when scaling. First is the vertical scaling, second, the trigger level, and finally, the horizontal scaling. Let's start with the first step, and that is vertical scaling, which, as mentioned earlier, will adjust the height of the waveform and make it appear either taller or shorter on the screen by increasing or decreasing the voltage. The value is shown in the display box here. Now, we will adjust the trigger level. Moving it above the peaks unsynchronizes the waveform, so let's move it down and see what happens. Find the right spot and move on to the horizontal scaling. If we turn the knob clockwise, the waveform is spread out and we see lesser number of cycles. The time values are again shown on the screen and on the bar here. To see more cycles, turn the knob anti-clockwise. You may find it useful to align your waveform to a grid point to calculate the voltage and/or time values for each cycle. For example, if the voltage is set to 5 volts and one cycle spans across 5 grids, each grid is therefore 1 volt. The same applies for the time axis. Activate the cursor button to display the cursors on the screen. A row of options will be activated at the bottom of the screen. Take note of the 3 buttons here. The x-axis button, which will only give you one cursor to work with along the x-axis. The y-axis button, also with a single cursor for the y-axis. And finally, the x-y-axis button, which gives you 4 cursors, 2 for the x-axis and 2 for the y-axis. Press the adjust knob here repeatedly until it highlights the cursor. To move the cursors, turn the knob as shown. With the USB already inserted, press the Acquire button. Ensure the Run Stop button is green in the Run position. At the bottom of the screen, you will see a row of options and their corresponding buttons. Select Memory Depth and choose 14K. This lowest resolution will give you a data file at a manageable size and also not overload the oscilloscope. Next, change the Run Stop button to red or the stop position. Then, as shown at the top of the screen, press the Save button. This will bring up the options again at the bottom of the screen. Press the Save Softkey button. Select your file format. For a screen capture, select Image. For the XY data points, select CSV. Then press Save again and save your file in the USB device. Physically remove the USB device when you're done. Set up your signal generator and breadboard as per instructions given in your prac manual. Then, connect the signal generator to the oscilloscope. Ask your lab demonstrator if you're unsure. The aim now is to set the waveform to the period and amplitude that will distinctly show you the charging and discharging of your capacitor. The period and amplitude are adjusted on the signal generator. We can determine the period by calculating the time constant of your waveform, which is usually 10 times the product of the resistance in ohms and capacitance in farad. Note that period is in hertz and the time constant is in seconds. We want the signal to almost cover the entire screen, and this can be adjusted by modifying your amplitude accordingly. Have about 1 or 2 cycles displayed on the screen. To freeze the waveform, press the Run Stop button and set it to stop, or red. Now you can analyze your data. We hope you have found this video informative and that you have a better understanding of the basic functions of an oscilloscope. If you would like further information, please see the additional information on Canvas or speak to one of your lab demonstrators. Thank you for watching, and we hope you're enjoying your time in PVB 203.